All right, now I went into a quick little video looking at the practicals that are stipulated in the syllabus. And these practicals we've done before, okay? So we're going to try and look at them and revise the concepts, but just a quick little look at these pracs because they're nothing new, but because they're stipulated in the module, we need to do and cover them. So let's have a look here. This is the syllabus point. It says predict the products. So let's just highlight the actual what it's saying. We need to predict the products, okay, of acid reactions and write balanced equations to represent the following. And so we're going to be looking in this video acid and carbonates. We have done these. We did this little reaction when it talked about the properties of acids and bases, and we also did it in year 11. All right, and so I'm going to show a video here in a second that's from one of the year 11 modules where we were exploring the carbonates. But let's just have a look at the setup here. This is a typical setup that we get. We get some calcium carbonate or marble chips. We put that into some acid. That of course reacts and produces the CO2 gas. It goes up. We collect it via a delivery tube and it goes into lime water, and that of course we use as an indicator for CO2 gas because the lime water changes color. Just test your memory cells. Can you remember why? Can you remember the equation that we wrote previously? Can you write that equation and relate it to the KSP value of calcium hydroxide? This is all about revision and active recall. Very, very important. So I just thought I'd bring that point up because that's what should be going through your head right now. Okay, and if you can't do it, highlight it and make sure you revise it. So we're constantly challenging ourselves to revise and intertwine this new information. So this is the setup. Now, as you're going to see in a second in the video, my setup's a little bit different. I'm using a round bottom flask. I've got the carbonate in the round bottom flask. I'm using what's called a thistle funnel, and that allows us to add other chemicals to a reaction flask. So here in this one here in the junior years, it's good enough, all right, because you add the acid and then you quickly put the cork on, but in the meantime you're losing gas. Well, if you want to become a little bit more sophisticated, and also if what you're doing is a little bit more dangerous, for example, you use this setup here. So we've got our calcium carbonate down there. We have a thistle funnel, and the thistle funnel is like this, drawn to perfection, okay, and then we have another glass tube coming out into our delivery tube, and of course that's going to go into our test tube containing lime water. All right, and so what happens if I just change it to blue, because that's the color of water or chemicals, we add the acid going in here. The acid now goes through there, it hits with the carbonate, starts the reaction, and then we collect all the gas. Remember, the initial gas in here is just oxygen, so the first lot of bubbles that you see coming out are not going to change the lime water, right? And a lot of students start panicking, going, it's not changing, it's not changing. And they do that in that high-pitched voice, it's not changing. And you go, remember, that's just the oxygen. And of course, after a while, the CO2 comes out, goes into the lime water, and that's when you start having the precipitation reaction to make it go milky white. So let's now add the video on top of what I've just drawn, and I'll just play it for you because this is a quick revision of the year 11 stuff. And well, actually I might just cover the whole screen, right? That way you're not watching me pretending to watch the video. All right, see you after the video. Here we are in the practical to do with acid on carbonates. And with this experiment, what we're going to be doing is taking it one step further than you probably did in year 10. We're going to look at a variety of carbonates here, and we can investigate, does the type of carbonate affect the rate of CO2 production? That's one possible experiment you could do. We could do it just by measuring with our eyes in terms of the rate of bubbles being produced, and we can do it more quantitatively as well. But what I've done here is I've got a variety of carbonates. I've got a flat bottom flask, and into that I've got a rubber bung with a thistle funnel. Now the thistle funnel allows us to add acid to the reaction and not lose any gas. In junior years, you probably just added the gas and then added the acid and quickly put the cork or the rubber bung on top, and that may have resulted in a lot of gas being lost. Well, we're going to be using a thistle funnel here. Then we're going to collect the gas, and the gas is going to go down and be bubbled through some lime water. So the classic test for CO2 gas. And so if there's CO2 present, it's going to go milky white. But if we wanted to do this experiment and measure the amount of gas, and let's say you wanted to do an investigation where we're using your understanding of moles to work out the number of moles of gas produced from a certain amount of solid or a certain amount of acid added, right? Because we've previously talked about limiting reactions, and we can work out which ones are limiting, and we can then calculate how much volume of CO2 would be produced. So we can actually measure that volume, and we can use something called a gas syringe here. And so we can attach this to the end of the syringe, and that will collect the gas produced by like that, and we can measure precisely the amount of volume. And by doing that, we can calculate the number of moles of CO2 gas. And of course, we could even calculate the number of molecules. So being more precise means that we have to use a Thistle funnel because we don't want to lose any gas. And so let's do that experiment. We're going to add the acid to there. You're going to see as it goes down the Thistle funnel, reacts with the carbonate, produces the CO2, gets up and goes through and makes that nice milky white color, which is indicative of a CO2 gas. All right, let's get started. Alright, so that's the video there, and we have some nice little background music there and some really close-up macro shots, which is great because it shows the beauty of the chemistry. Now, our dot point said that we had to predict the products and write an equation. So let's just revise that concept and see how we go there. So remember, if we have some sodium, hydrogen, carbonate, and we've experienced that before in our previous videos of naming acids, and we add that naming bases. We have this base. It's actually a salt of a base, right? We'll talk about that later. But there is our base, and here we have our acid. So let's say we add some HCl. Then we have to predict the products, and of course the products in any acid plus carbonate gives you a salt plus water plus CO2. So what's the salt going to be, here you ask? Well, this is what it's going to be. We're going to get the sodium. That sodium is going to be combined with the chlorine to give us sodium chloride. That's aqueous. And then of course we've got the CO2 gas forming, and then we've got our water. Okay, so now that is an equation, and it says balanced, so let's just check out to see if it's balanced. Okay, we've got one sodium here, one sodium there, one chlorine, one carbon, 3 oxygens, 3 oxygens, and 2 hydrogens, 2 hydrogens. It's already balanced, we don't need to do anything. But let's just create a net ionic equation here. So of course we're going to bring the sodium by itself, and I'm just going to, don't worry about writing the states, but of course in exams you do. So then we have the hydrogen carbonate ion. Then we have the H plus from the HCl, because that is a very strong acid which completely dissociates. We're going to talk more about that later. Then we have our sodium ions and our chloride ions. Then we have our CO2 gas, and we have our water. Okay, so we get rid of those ions that are spectator ions that do not take part in the equation. So that's that. So let's get rid of them with an eraser now. Get rid of that. I'm just going to make the eraser a little bit smaller. Get rid of our chlorine. Okay, get rid of our sodium and our chlorine. And so what we've got here is we've got the H plus, and we've got a hydrogen carbonate ion, and then we've got our water and CO2. Okay, and now this is a neutralization reaction. So what's sort of going on here? Well, the really crazy thing about this is that this here is a neutralization reaction. We've got a solid here, and then we've got all aqueous over this side, except for the CO2 gas, which escapes. And so this is what's sort of going on, and we're going to delve more into this system, because a neutralization reaction is basically where you have a H plus and OH minus combining to give you water. Okay, and we can see the water there. Right, we can see the H plus there, but we can't see any OH. What's sort of going on there? Well, that OH is coming from another sort of reaction that's occurring at the same time here with water. We're going to explore that concept a little bit later on when we delve deeper into this acid-base topic. So that's hydrogen carbonate as the police or whatever go past. And then we have sodium carbonate. Okay, and then we could do the same thing. So let's just change the acid. I'm just going to erase that out. I might actually erase everything out. So if you haven't written that down yet, make sure you press pause, write it down, because it's going. There it goes. Pew, gone. All right, so we're going to do some sodium carbonate. I'm going to change the acid on you because HCl is done to death. Let's do a different acid. Let's do sulfuric acid. What's the formula for sulfuric acid? That's right, H2SO4. If you don't know it, go write it 50 times. Right. Then we have the products. What could the products be? Well, the products is a salt. And so we've got our sodium here, our positive ion, combining with the negative anion over there. So that's going to make some sodium sulfate. And that's aqueous. Okay, because remember all group 1 cations are soluble. All right, see what I did there? Revising all the time. Okay, and then we have our CO2 gas, and then we have some water. All right, so that is that. Now we need to balance that. Well, let's just change colors, because when we balance, we like to change colors. And so we have 2 sodiums here. We've got 1 there, so let's put a 2 in front of that. That means error. Okay, I've found, this is what happens when you get tired, but let's have a look at what I've just done there. Let's get rid of that 2, and I can't do that because I've got the formula incorrect. Right, that's better. There we go. Okay, now let's check out about balancing it. All right, 2 sodiums, 1 sulfate. We've got 1 carbon. We've got 3 plus 4 oxygens, which altogether makes 7. So we've got 4, 5, 6, 7 oxygens. Okay, and the hydrogens 2. So that's all balanced. So there's just 2 examples of acid on carbonates. I would recommend that you find other equations and practice them. So in other words, instead of using hydrogen carbonate, sodium carbonate, find another carbonate. You could use calcium carbonate. And what would happen if you did that with nitric acid? I wonder. What would the equation be if you were to do that with, let's say, acetic acid? CH3COOH. How would it be different if you were to use citric acid? So find different acids and just balance the equations. Challenge your friends and see that, because you know that's what they're going to do in the HSC. They're going to give you different acids that are unfamiliar, and you still have to be able to balance the equation, right, and predict products. All right, so that's it for this little quick video. Hope that makes sense. I'll see you in the next one where we start looking at acids and bases, and which is just neutralization, and when we look at acid and metals. Once again, revising the concepts, but taking a little bit of extra new things from it as well. All right, see you in the next video. All right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.